Hey, hi all, good morning. Yeah, let us start today's session. It's a continuation for yesterday's session. Yesterday, based on yesterday class, few members had a few questions like, what do you mean by a storage staging area? And one member asked to explain more in detail about the ETL process. So today we will focus on what do you mean by. I want to try and explain about what do you mean by staging area. I want to clear the doubt about that. And again, I want to explain about the ETL process. Though we don't perform any ETL process, it's better to have an idea. It's a nice question. Yesterday, one guy asked to explain in brief and detail about the ETL. Okay. So coming to yesterday class, there is a one doubt which was raised while we are speaking about the staging area. One guy asked about what do you mean by staging area? Want to require few details. And again, after the class, also different resource had asked to explain about the stage. What do you mean by the stage area? So I want to explain more in terms of how the word had came up as what do you mean by staging area. So if you can see here, this is the real-time warehouse, right? It's a normal warehouse. I'm not speaking about the data warehouse like that. It's a warehouse which we see in the real-time environment. If you have visited any of the warehouse, this is how it looks like. So before the goods move to a storage area, initially, when the truck arrives, the all the goods which was present in the truck is loaded into a temporary storage, temporary area. This is a this is what a staging area is known about. In terms of in terms of warehousing terminology, logistic environment also, this is known as a staging area. Before moving the data, when we are trying to replicate the same into the data warehouse, so before moving the data into the destination tables, we are temporarily moving data into the staging area. Stage area is nothing but a temporary location where we are going to park our files or data temporarily before moving into the destination tables. Hope this is clear. With this, I brought you a similar images in this image also. So here we are performing the it's a part of ETL, right? So after performing the extraction transformations, we are going to move with the objective is to move data into the destination tables. Before moving the data into the destination tables, we are temporarily parking the data into a staging area. It's a inbound staging where we are going to where the data is arriving into the database. It's known as a inbound staging. Okay, this is one more big. So here the data, it's a inbound staging area. Once the data is running after extraction and transformation, the data is moving into the staging area here. And then the data is moving into the destination tables. Here, in reality, it's a goods, which is when the goods are arrived, you're going to unload the goods into the temporary stage area. Then it will move into the different tracks. This is what the staging is nothing but a temporary storage of data. Temporary storage of data before moving into the destination tables. Hope I have cleared this. What do you mean by a staging area? Just remember that it's a temporary storage of data before moving into the destination tables. It's what the staging means. Okay. Hope I have cleared. Any doubts? Please raise it here. Yeah. While moving to the yeah, I'm moving to the next topic. One person asked me explain about in detail about the ETL process, how the ETL happens, what is the objective of ETL and all. So, as discussed yesterday, ETL stands for extraction, transformation, and loading. Transform. I mean, in the transformations, performing certain level of modifications in the data is known as a transformations. So, E stands for extraction. Here we have a multiple database systems like OLTP systems. We need to extract data from vast variety of sources. Some data will be stored in one database. The data might be in XML. From one database that we might be receiving. Yeah, am I not audible to anyone? Can someone confirm?
You're audible.
Yeah, I'm audible, right? Yeah, okay. Yeah, someone is saying that I'm not audible. Yeah, fine. Thank you. Yeah. So the process of once you need to check your audio connections. Actually, my voice is clear and some majority of the people are audible. I'm audible to them. Yeah. So sorry. So in the ETL process, we are going to extract the data from multiple variety of databases. It could be from data. We might be receiving data one in terms of XML files, one in terms of CSV, one data in terms of PDFs, and in the vast variety of sources. Okay, we need to extract wherever the data has, wherever in whichever format data is present. We need to connect to the. We need to create a we need to establish a connection to different data sources, and we are going to extract the data in extraction. Okay, we'll extract the raw data. Once the raw data is extracted, we need to understand that in generic the extraction is nothing but we're going to retrieve and collect the data from variety of sources. We have a multiple database systems. We need to connect to the multiple database systems, and we are going to fetch the data. The data would be in a different formats and structures based on the different organization requirements. Okay, so we are going to the major objective of extraction is to obtain the high quality of data. We are going to extract the data as is. So we have the raw data, whichever is the data which is present. Then once we receive the data, we need to perform the transformation. The transformations could be as simple as possible and could be as complex as possible. The basic transformations. So we have in the first step, we have established a connection to different databases, and we have extracted the data. The next step is to perform the transformation. In order to perform the transformation could be as simple as data cleaning. Here, data cleaning in the sense that let us consider there could be what the data which we receive consists of a multiple null values. So our requirement says that change the null values to a 0. So it's a one type of cleaning. Again, let's consider that some in terms of there is a field called as a parent. In parent, we need to determine it as a p. There could be some fields which has a father, which has a mother. There could be guardian. So we are going to change all the fields and make it same across the column as a P. If the P means it needs to indicate a parent. C means child. Instead of son, daughter, we are going to modify it as a C. So we are going to clean the data so that it was data would be ready to perform the analysis. So, okay, that's the one step of transfer. Even you can say the data cleaning as a data transformation in perspective of ETL. Whatever I'm explaining today, we need to have a thought process in terms of ETL, what the ETL guys are doing, not in terms of Snowflake transformations. And we need to consider this we need to consider this in terms of ETL developers and ETL tester point of view. Okay, data cleaning is one kind of transformation for a ETL guy. Okay, next coming to the whatever the data that we have received from the multiple data sources, there could be lot of duplicates. So we need to validate, we need to verify whether the duplicates are present or not. I mean to say, we in the perspective ETL guys, they are going to look into the data and they are going to remove the duplicates, whatever the data duplicates are present in the data. Then are going to in then the next step is going to be a data format revision. Data format revision speaks about that. Suppose some people might scale the height in terms of centimeters and different people in terms of inches. So in order to keep it constant across the system, we may use either we may use either inches or centimeters. Here the example they have quoted was either kilograms and pounds, whatever the data is present. So we are going to make it as a either kilogram or a pound. This is also one kind of data transformations from ETL perspective. These are going to be basic transformations. Either it could be a duplicate data cleaning, removing duplicates and format revisions. And there could be they can perform some sort of complex, not into a major complex transformation in Snowflake perspective. From ETL point of view, the complex transformations could be include. Yeah, give me a minute, guys. Yeah, sorry guys. Yeah, from ETL perspective, these are the basic transformations like data cleaning, data removing data duplicates, and data format revision. They can perform some certain complex transformation as well, like performing the derivation. Derivation in the sense that here, in order to, let us consider we have buy one item. So for one item there are two vendors. Okay, instead of giving the price for the two vendors, we are going to club the A plus B as we are going to include in a single price. We are going to perform certain derivations. Then we are going to perform the certain basics of joinings they can perform. They can, let us consider in terms of splitting here. If you have a name as a John Doe, we need to split into the first name, middle name, and last name. This is also one type of transformations. We can summarize, we can perform the all the, let us consider that there is a list of items where the person had purchased, and we need going to calculate the summary sum of the whole entire values of it. It's called a summarization. There could be some sort of sensitive data where they need to perform encryption in order to showcase, in order to avoid the showcasing of exposing the data to everyone. We are going to perform the encryption. These are the simple level of transformations and complex level of transformations from where the ETL guys perform. Okay, then yeah, any doubts so far in terms of what do you mean by a ETL? I mean to say in terms of extraction and transformation. So extraction is connecting to the multiple variety of sources of databases and pulling the data into our environment. Then we are going to perform the transformation. The transformation could be as simple as data cleaning, removing duplicates, and data format revision. Either it could be performing, either it could be performing the joinings, splitting of data like that. These are going to be a complex transformations. Like from ETL point of view, these can be considered as a complex transformations. But from the Snowflake point of view, it's very simple transformations. Okay. Any doubts in terms of transformation, extraction and transformation, right?
This work will be done by the ETL developers,
Yes,
or
exactly.
we will did
No,
this.
ETL, all the whatever
We
I'm saying now, this could be performed by a ETL guys. Our
Okay.
transformations will be a little more complex. We perform in terms of business level. Business level, we Snowflake developers, we consider in terms of business end users, and we model the data. We transform as per the requirements of the business. Okay, but whereas here ETL guys, their main objective was to present the data for the Snowflake developers in order to implement, in order to incorporate the business logic. Their essential duty or responsibility would be like providing the data as good as possible and helping the analytics guys whoever perform the analysis. Yeah, any questions?
We for this one we need to have a ETL knowledge or
No,
anything
no, no.
about this.
ETL knowledge is not required for in order to work on a Snowflake. ETL knowledge is not required, but actually you need to have an understanding of ETL. Or basically, how the actually it's a pre-process, right? Snowflake sits in the middle. Just I want to Snowflake sits in the middle actually. Yeah. So give me a minute. So what happens is here there will be a ETL on our left. If you want to be a Snowflake developer, here we sit a Snowflake. Here the reporting tools. Okay, ETL is a pre-process. Whatever the data that we receive, whatever the data that we need to push into the Snowflake is done. Pre-ETL is a pre-process of Snowflake. The data which is present in the Snowflake are going to utilize it by the reporting tools. Reporting tools guys like Power BI, Tableau like that. So we need to have a basic understanding of ETL and basic understanding of reporting tool. Either it could be Power BI, Tableau like that. We need to know on a high level, we need to know the knowledge. What do you mean by ETL? Why the data extraction? How they are going to extract the data? And what is the basic transformation that are going to perform? And what are the different types of loads that they have? Okay, it's not the essential, it's not very essential to learn any of the ETL like Talent, Alteryx. If you can learn any of the ETL, then it could be like we can move into the ETL developers or ETL testers. There are very popular tools like Informatica, Alteryx, Talent, Matillion. There are a lot of ETL tools, right? Apache, NiFi, like that. For Snowflake, in order to learn the Snowflake, ETL is not required. ETL knowledge is not required, but it's good to know the ETL process. Yeah. Any questions? Part of that. These are the basic transformations like that. Then moving to the data load. The data here, the object data load, the ETL guy's responsibility is to move the data into the staging environment. They are going to load from, they are going to perform the, they are going to perform different from the different OLTP systems. They are going to extract the data and they perform basic transformations and load the data into stage environment. Loading the data can happen in variety of ways based upon the requirement. They can perform the full load in the sense that they are not going to, they are going to entire data which is present in the OLTP system, they are going to fetch it and they are going to load into the stage environment. It's known as a full load. Coming to the incremental load, let us consider incremental load in the sense, yesterday we have a two records. Okay, these two records, staging environment, they have loaded into the staging environment A and B. While in terms of full load, the ETL guys will going to, let us consider yesterday these are the records that have loaded into the staging environment. Today we have A, B and C. So ETL guys in terms of full load, they are going to truncate truncate this table and they are going to load A, B, C and all the records whichever is present. This is nothing, this is known as a full load. While coming to the incremental load, yesterday we have two records, right? And the new record which got added today would be C. In case of incremental load, whatever the data that is present in the newly added data is going to move into the stage environment. This is known as a incremental load. Okay. In incremental load, we have a two, again it was divided into a two different ways of loading, which is known as a stream incremental load and batch incremental load. The difference between the stream incremental load and batch incremental load is, in batch incremental load, we are going to perform the load based on a batches. Let us consider if there is a high volume of data, so it could be like hourly, whatever the new data is had come, only the new data which was arrived in a batch, we are going to move into the stage environment. It is nothing but a batch incremental load. In case of streaming incremental load, the loading is going to be a continuous. See here, I have, in case of batch ETL, it could be once the extraction and transformation is done, we are going to load the data into the staging environment based on a batches. The batches could be like hourly, it could be weekly, monthly, daily, it depends upon the business requirement. This is a batch ETL loads. Whereas the stream ETL load, it's going to be a continuous. Once the, if you are going to notice certain change in the source, we are going to fetch the data, we are going to transform it and directly load the data into the destination stage area. This is what the difference between the different types of loads. Okay, we have a four major types of loading, which is a full load, incremental load, a streaming incremental load, and batch incremental load. This is what the difference is. In case of full load, we are going to truncate entire table and load the entire table. Whereas incremental, we in Snowflake we have a concept like change data captures. How we are going to perform the incremental loads using the change data captures. We'll discuss about that later. And incremental load, we have two different types like streaming incremental load and batch incremental load. This is what the how the loading mechanism works in case of the ETL. Hope you have everyone had understood the ETL process. Just ETL process is nothing but a extraction, transformation, and loading. We are not going to involve very much detail in this process. ETL guys, it could be ETL developers and ETL tester take care of this, and they are going to load the data in a stage environment. Once the data get loaded into stage environment, from here our responsibility comes into picture. Okay. Any guys, sorry, any doubts so far regarding this ETL? Hope everyone had understood this ETL process. This is a pre-process prior the process which happens prior the data arrives into the staging environment. Once the data is arrived in the stage environment, from here we are responsible. We'll discuss from here what happens and how we are going to share the data into the downstreams. Okay, this is what the process of ETL. Okay, yeah. If there is no doubt, I'm moving to the next one. Okay. The first topic we need to understand is about the OLTP and OLAP systems. Okay. In order to before going dwelling deep into the Snowflake, we need to understand what do you mean by a OLTP systems and OLAP systems. Here, OLTP stands for Online Transaction Processing and OLAP stands for Online Analytical Processing. See, TP stands for Transaction Processing, AP stands for Analytical Processing. Yeah, any doubt? Someone is rising? Yeah, if there is no doubt, you can keep in mute. Yeah. Coming back to the session, TP stands for Transaction Processing and AP stands for Analytical Processing. Okay, transaction in the sense that you need to understand it's the smallest unit of work. If you are going to perform, hello, Ganesh, can you please go on mute? Do you have any doubt, Ganesh?
No, sir, no.
Yeah, fine, thank you. Can you go on mute, please? Yeah, thank you. Yeah, you need to understand here. The first essential requirement was you need to understand what do you mean by OLTP systems and OLAP systems. If you are clear on this concept, you will be moving forward very easily and have a lot of confidence that what you will have a lot of confidence that on what we are working on. Okay, OLTP sense that OLTP is nothing but a transaction processing. Whatever transaction processing, it's going to utilize by a lot of users. Okay, it's in order to enable the here we are going to have a I will give you a basic example of transaction processing. Let us let us consider we have a Amazon website, right? In Amazon website, lot of users are going to place an order on a regular basis. Okay, in Amazon we have a different databases like sales database, orders database, HR databases, and like that. Okay, these databases are known as a OLTP databases. Whatever the data that is present, if these databases are used for day-to-day transactions. Okay, these databases are used for day-to-day operations. Once the day-to-day operations, once the data, once the day-to-day operation, once the day operations end, we are going to move this data into the OLTP databases. Sorry, OLAP databases. Why? Because we cannot perform any of the analysis in the OLTP systems. These transaction database are used for to having the day-to-day transactions only. And the space of the OLTP systems is very low. And the space of the, I mean to say storage of the OLAP systems is very huge. Once if you are going to let us consider as per the business requirement, we are going to store the data in the OLTP systems for 30 days. Once the 30 days ends, whatever the data for these 30 days will be moved to the OLAP systems. This is going to be a continuous process. For every 30 days, we are going to move the data into the OLAP systems. Okay, why? Because the storage space in the OLTP systems is very less, and this is performed. These databases are used to perform the day-to-day transactions. These OLTP systems enable us to perform the rapid movement. I mean to say across the bank ATMs, online bankings are one of the examples of the OLTP systems, whereas analytical processing systems or analytical processing databases are used to perform the analysis. Transaction processing databases are used to perform the day-to-day transactions. The examples of transaction processing databases are Oracle, SQL Server, whatever the RDBMS, majority of the RDBMS. And the analytical processing databases are Snowflake, Redshift, Azure Synopsys. These are the major examples of analytical processing systems. The major characteristics why we are going to use the transaction processing systems are the transaction processing systems can provide the large number of can enable to use at a time we can going to use large number of transactions can happen in the OLTP systems. So there could be a lot of people who are using the credit card transactions at the same time. I mean to say withdrawing amount from the ATM at the same time. We have a multi-user access. At a time users can access the single databases while ensuring the data integrity without any I mean to say we have a two commands, either the transaction is success or fail. We have only two states. Okay, it is available across the 24 by 7. These OLTP systems will be enabled and available across the 365 days. Okay, This is what the characteristics. We are going to perform the large transactions are performed by a multiple users. These are going to be major characteristics of transaction processing systems. Okay. Some examples of transaction processing include like ATM machines, where we are going to multiple users can access ATMs at the same time. Okay, credit card payments are one other example. Orders entry, different people can place the orders at the same time. Okay, these are the few examples of the OLTP systems where they are going to help us to keep the records on a day-to-day transaction activities. Okay, and coming to the OLAP systems, once the transactions are happened securely, depending upon the requirement, we are going to move the data from OLTP transaction processing databases to the analytical processing database. It could be done weekly, monthly, depending upon the requirement. Okay, the basic difference between the transaction processing systems and the analytical processing systems are these are going to utilize in the real-time executions for in order to transaction processing systems are used to have the large number of transactions at the same time, whereas analytical processing systems it involves the very less transactions. I mean to say very, there are very less people are going to use when compared to the transaction processing systems. If you're working on a Snowflake, we can notice only few members, around 200 to 300 members who have the users into the Snowflake. If you consider the transaction processing, every user, most of the users are writing data into the transaction, where write operations occur more in the transaction and more read operations occurs in the analytical processing system. Okay, the response time in the transaction processing must be very high. Suppose let us consider if you are going to withdraw money from ATM, the transaction must response time must be very high, whereas in the analytical processing the response time will be very low, as we are going to perform the complex, I mean to say we are going to fetch the data from millions of records. So the response time will be very low compared to the transaction systems. Okay, here small amounts of data, we are going to work with the small amounts of data in the transaction, whereas in the analytical processing we are going to have a huge amount of data. Okay, we are going to store more amount of data. The storage space is very high in analytical processing and very less in transaction processing. We can write a simple queries to fetch the data in transactions processing databases, whereas we need to write a complex query summary. We need to use a lot of analytical methods to perform the to fetch the data as per the business requirement and to generate the reports. This is what the major difference between the OLTP and OLAP systems. So on a high level, you need to understand that OLTP databases are used to perform the transaction day to run the business day to day, to run the day to day business, whereas analytical processing systems are used to understand the how our business happens over the period of time in order to perform any of the analytics. Either it could be descriptive analytics, predictive analytics, or a preventive analytics. In order to perform any kind of these analytics, we are going to utilize the OLAP systems. Hope I am clear about what is the difference between the OLTP and OLAP systems. Any doubts so far? We are going to work. Snowflake is a OLAP system where we are going to perform the analytics. Okay, either it could be there are different types of analytics like descriptive analytics, preventive analytics, predictive analytics. Based upon the requirement, if you are moving into the ML machine learning, we might be learning with the help of data. We are going to learn about the supervised learning, what do you mean by a supervised learning, unsupervised learning? There are different types of machine learning techniques like nearest neighbor. There are different ways. Over the progress of time, we need to explore more into that areas. Okay, any doubts between the what is the hope you have understood the difference between the OLTP and OLAP systems. Okay, yeah.
Your voice is breaking.
Even now, from long time or now just now? Hello?
No, just last 30 seconds. It's fine.
Okay, okay, fine. Okay. Oh, sorry, thanks for that. Now it's clear, right? Yeah.
Yes.
Yeah, okay, thank you. Okay. If you have understood this OLTP and OLAP systems, yeah. Then moving on to the next topic, we need to understand about the we are now our objective is to learn the about OLAP system. We have major OLAP systems. Just I'm using the word system. You consider it as a database. We need the objective is to learn about the OLAP databases. Okay, we have multiple OLAP databases which are very familiar in the market. Was earlier prior to Snowflake. We have a AWS Redshift, and the competitor for the AWS Redshift had come up with the Azure Synapse. This is from AWS, and Azure Synapse from Microsoft, and there is a Google BigQuery. These are the major players prior to Snowflake. Consider the scenario that having the major players in the market like Microsoft, Google, and Redshift, there is a one player that had come into the market as a Snowflake in terms of OLAP in competition with OLAP databases. So Snowflake is surviving despite of all these competitions from the different. These are the technically these players are very strong in the market. If we consider AWS, Azure, Microsoft, and Google, despite of these tough competition, Snowflake is able to survive, and there is a huge growth market for the Snowflake in terms of OLAP databases. Okay, the what makes the Snowflake so different when comparing to its competitors like AWS, Azure, and BigQuery was the beautiful architecture that was built in a Snowflake. Okay, the objective here was to learn about the OLAP databases. There are the different OLAP databases. I mean to say data warehousing tools. In speaking in a normal language, like data warehousing tools, we have a AWS Redshift is a data warehouse tool. Synapse and BigQuery is a different data warehousing tool, and Snowflake is also one of the data warehouse tool. Despite of this tough competition, Snowflake is able to survive and have a very growth market in the current industry. Why? The reasons was it provides some of the best features in the market, and the one of the major advantage was its architecture. The architecture was designed in such a way that it was a decoupled architecture. Decoupled in the sense they have divided the storage layer and compute layer. We have a decoupled architecture like storage layer, compute layer, and cloud services layer. Earlier in the scenarios, what happened? Whatever the architecture that was built by nowadays Redshift, Synapse, and BigQuery also had come up with a decoupled architecture. So all the storage and compute layer, moreover, they are in a same layer. So it was very difficult to perform. I mean to say, it was difficult to increase the size of a storage or size of compute. So these are the basic drawbacks of from these systems, from these databases, which Snowflake has overcome very intelligently. What the Snowflake has done was they have separated the storage area from the compute area. So in Snowflake architecture, we have a three layers. One is a storage layer which sits at the bottom, and middle layer is a compute service layer, and the top layer is a cloud services layer. Okay, this is how I mean to say this is what the Snowflake had done. We will discuss about the Snowflake architecture tomorrow. Yeah, okay, Snowflake architecture tomorrow. We'll go in detail about that. Before going to that, we need to understand what do you mean by a on-prem databases and cloud databases. Okay, on-prem database is something that where the data, if you have a on-prem database in your organization, means it says that you are going to have your physical servers are located in your presence, and you are going to maintain all your servers, and you are going to take care of the security, you are going to take care of the power and everything for these servers. Okay, whereas the cloud servers, we are not going to take care of anything. We are not going to take care of physical server presence. Cloud is nothing but a someone else's system, that's all, where we don't know where some it sits on a somewhere, but it's also one of the computer similar to the server. But whereas in terms of on-prem, our data we know our it's in our premises, and we are going to take care of everything. Whereas coming to the cloud, the storage is provided, storage and in terms of compute is provided by some different vendors like AWS, GCP, and I mean to say Azure. Okay, they are going to provide some physical space and some compute power. We are going to utilize that. Okay, the Snowflake is going to be a cloud database, cloud data warehouse. Snowflake is going to be a cloud data warehouse. It's not going to be, you cannot have a on-prem cloud data, on-prem Snowflake. We are going it, exclusively Snowflake works with a cloud data warehouse. Hope you are able to follow me. What is the difference between the on-prem and cloud? On-prem in the sense that we can see the physical server in our organization, and we are going to take care of everything of it maintenance, power and cooling and everything. Whereas in the cloud, the the server and compute power is provided by some vendors. If you can choose, we have a three vendors where you can choose from AWS, Azure, and GCP. Okay. Any doubts in terms of categorizations between the on-prem and cloud? Hope everyone able to clear. They can see a lot of new people where they don't have a knowledge on cloud. Just try to understand the terms.
Yeah, Mohan.
Yes, yes,
Hello.
yeah,
Yeah, Mohan. This is Raghunath.
yes, Vinay.
Actually, now real time they're using like cloud they are using or what
Yeah,
database?
yeah. Actually, Snowflake will work with only with the cloud. Either we need to choose
Actually,
whether we need to. I mean to say, organization choose whether it can work with the AWS, Azure. We have lot of different cloud vendors which can provide. So that organization need to choose whether
actually,
the Snowflake need to choose whether need to work with a GCP, Azure or AWS. We have a multiple vendors
yeah,
like
I seen
IBM.
that.
Yeah,
Yeah, yeah, I seen that the cloud is cost is very high. I observed that everything. That's why nowadays we are using on premises only. I think so.
no,
Actually,
no,
data cost is very, very high, right? If
no,
you
no, no.
if you
Actually,
take like
yeah, yeah. Please go ahead. Yeah, complete
yeah.
your thought. I will explain you correctly. What?
Yeah, cost is very high means it's like I observe like cost is very high actually. If you take 100 TB or they are not used right, they will use some less expensive right. If you use 0.5 TB, if you use means total is like 100 TB is waste right. It go to the on-premise is best right actually.
Okay. Yeah. Just I want to clear your
Yeah,
understanding. On-premise in the sense that
yeah,
you need to have, I mean to say, capital, you need to understand in terms of capital expenses and revenue expenses, right? Just I'm trying to explain you in
mm,
terms of capital expense. We have a two words first, revenue, capital expense, and another word I don't remember in terms of financial aspects like revenue maintenance. Let us consider it as maintenance expenses. Okay. If you want to build a on-prem data means we need to acquire the servers. Okay, we need to acquire the physical space. Okay, let us consider that we have acquired the server which can store up to 10 TB. Okay, so we are going to build on-prem means physical location. Okay, on-prem means we are going to build the services by ourselves. So we are trying to build on-prem database which can store up to 10 TB. Okay, so that we need to acquire the server. We need to first initially we need to buy a space for that in order to establish the server. Then we are going to have a servers in that, and there we are going to, this is nothing but a capital cost, buying the space and buying the servers and everything, electricity maintenance. Okay, these all this comes under the maintenance cost. Okay, this is going to be a, when you are going to build an on-prem server, these are going to be a cost that we are going to incur. Okay, so our requirement was from the since the date of since the starting of day one of our business, we are not going to start with the 10 TB of data. Our requirement, our estimate says that we may have at max our sales can reach up to a 10 TB of data storage. Okay, this is what the case of on-prem. Now let us move to the cloud. Okay, in cloud we have a different major vendors like AWS, Azure, GCP. These are the three major players where they are going to provide the cloud service. Okay, let us consider that you want to, in case of on-prem database, if you want to start a business from tomorrow, it's not possible. Why? Because you don't have any of the database, any of the servers ready, space ready, and any of the thing ready. If you think today, it may take several next few weeks to months. next few weeks to months to start to run your business smoothly in terms of on-prem databases. Let us consider that in case of cloud scenario, today you got an idea, and from the next minute onwards you can have the cloud database ready, you can have the servers ready, you have the servers ready, you have the compute ready. And in the cloud we have pay as you go. You have the concept like pay as you go. So here you are going to acquire the space of server for the 10 TB. Initially you are going to pay all the worth what you are going to incur, though you are going to store only 1 TB or 1 GB of data. But whereas in a cloud, pay as you goes in the sense that if you are going to if you are going to occupy a space of 1 GB, then you are going to pay a space for 1 GB only. We are not going to your business requirement to us to have a 10 TB of data. But whereas as the data gets gradually increased, then only you are going to pay. When you are going to occupy entire 10 TB of data, then you are going to pay for it. Before that, you are not going to pay anything. Whatever the data that you are going to store in the cloud, for that amount of storage only we are going to pay in the cloud. We are not going to store, we are not going to pay for 10 TB of data. Hope you are able to follow me,
Okay, I
right?
go. Yeah, I got it. Yeah.
Yeah. So the
Yeah,
problem here is
whatever we use it, we have to pay. Yeah,
exactly
whatever we
whatever
have
you
to use
use
it,
it,
we
we
have to
have
pay
to
that
pay
only.
in the cloud. So
Yeah,
if you want to
yeah,
start your business, consider that if you want to start your business so if you are going to have an on-prem database, then you cannot start directly from tomorrow or day after tomorrow. It will take lot of time to build your I mean to say to build your cloud or to build your on-prem architecture, what could be payment systems, and you have a headache of taking care of everything, security and everything. You need to take care of cooling, internet connections and everything. But cloud is automatically it was ready. If you have a basic internet, then you can go further. From the next moment you have the capacity, whatever the data that you have, you can store it, and you will pay only as you go. This is a concept like pay as you go, which will be incorporated in the Snowflake architecture. Tomorrow I will explain you the Snowflake architecture and the billing, how it happens, what is the storage cost that you will incur, what is the compute cost that you will incur in Snowflake. Okay, hope you are clear,
okay.
right? Why cloud is preferred nowadays. Okay, let us consider
Yeah, I think.
you have built a on-prem for 10 TB. Suddenly you have a requirement where your data was increasing up to 200 TB. You don't have a capital expense. You need to incur lot of capital expenses incurred to build again 200 TB of data. But whereas in the cloud, you don't need to incur all the capital expense. Directly you will take a rent. I mean to say utilizing it's taking rent. Someone computer is taking rent cloud. Whereas in the on-prem, we are going to buy it and we own our own computers. In the cloud, just we are renting from someone else. That's the difference in generic way. Okay.
Yes, yes.
Yeah, hope you got that. It's clear, right? Why cloud is preferred. Tomorrow you will
Yeah, it's
come to
clear,
know
but
about you will
yeah,
come to know about how the billing happens, how what is the I mean to say storage cost incurred, how the storage cost is incurred, and how the I mean to say how the compute cost is incurred. Okay, this is and yes, we are discussing that. Just I want to explain you two concepts like elastic storage and elastic compute. So in terms of elastic storage, if you can see here, we have a 10 TB of data in on-prem. So we can let us consider that only if you want to, our requirement was we have a bucket of 3 liters, right? This is a bucket of 3 liters. Let us consider that. Okay. We have a data of 5 liters. We have a quantity of 5 liters which need to be filled in 3 liters. So it is not in whatever way it is possible. It's not possible to fill the 5 liters 5 liter of quantity of water into a 3 liter bucket. So we when it's possible, there is a chance it's possible that if it is going to be elastic, let us have that this this bucket is going to be elastic bucket. Okay, how much water you pour it, it's going to be elastic. The size of the bucket is going to be increased. If you are going to if you are going to fetch the 20 liters of 20 liters of water, and if you are going to pour into this bucket have the capability of being elastic, and it will going to be increased as per the requirement. Let us consider initially we have our requirement says only 3 liters, so we have brought a small bucket which can occupy 3 liters of water. Then our requirement changes suddenly to a 30 liters. So we have the wonderful bucket known as the elastic bucket, where it can increase the size till it can occupy 30 liters. If our requirement changes, no, our requirement was only for 3 liters, so the bucket can have a capability of decreasing its size to 3 liters only. This is what, if you are going to relate the same example over here, the elastic storage here, on-prem elastic storage, we have the capability of 10 TB. If you are going to push the another TB, 1 TB of data, 11 TB of data into on-prem, it doesn't occupy. But whereas in the cloud, it has the capability of elasticity in nature. How much the data of you push into the cloud, it will occupy. You can store the same compute, same storage. Even it could be 200 TB, 300 TB. The cloud is going to be elastic. That is known as a elastic storage. Okay. So let us consider that in terms of on-prem, we have established around 20, I mean to say 32 GB, 32 GB RAMs. Okay. We have 32 GB RAM. Our compute node requires the 64 GB RAM. Okay, in order to process in a particular in order to process a particular data, we require 64 GB RAM, but we have only 32 GB RAM in our on-prem. But whereas in the cloud, we have the feasibility of choosing our own compute resource. What number of compute sources, compute services that we require, we can choose. These number of servers can be used to utilize the perform this action. The elastic compute could be vertical. It could increase vertically. I mean, it could be vertical. It could be elastic even vertically and horizontally. I will explain you what do you mean by horizontal and vertical, and we can wrap this session. Yeah. Just I want to explain you these two concepts: vertical elastic and horizontal elastic. So in terms of vertical elastic, so let us consider that here A can do a work, A can pull 30 kgs of weight. Okay, if he has the power of, let us consider he has cover of 2. Okay, so what happens is we ask him to pull the 60 kgs of weight. So we are going to increase his capability to 4 so that he can pull 60 kgs of weight. Okay, this is what it happens. Whereas in the horizontal, so let us consider that A can pull 30 kgs. Okay, so we are in horizontal, we are going to add, in order to fetch the 60, in order to push the 60 kgs, we are going to add another resource A comma B. So A can, considering A can pull the 30 kgs, B can pull 30 kgs, we are adding additional resource in here in terms of horizontal elastic. Tomorrow I will explain you in terms of Snowflake how it will act. Generally I want to give you a brief idea in terms of what is meant by horizontal and vertical. Okay, in vertical we are going to provide the extra effort, we are going to increase the power of a human so that he can push the 60 kgs by adding increasing 2 to 4. Whereas in the horizontal we are going to give an additional resource to help him. Okay, this is what the difference between the elasticity being vertically and elasticity being horizontally. Okay, once tomorrow if I explain in terms of, in while discussing about the Snowflake architecture, it will be clear, it will give you a clear idea about it. Okay, any doubts so far? Whatever the topics, the, I mean to say, what the main takeaway of this session should be like, what do you mean by, you need to understand what do you mean by OLAP systems, as we are going to work with a OLAP systems. There are multiple OLAP players in the market and we are chosen to learn the Snowflake. Why Snowflake despite of all these competitors, means from tomorrow we will learn that. And one more takeaway is we need to understand what do you mean by ETL process and ELT process. Just you can explore more in terms more about it. You need to have a basic idea what do you mean by extraction, what do you mean by transformation, what do you mean by loading. That gives you a lot of advantages to learn. Okay, any doubts, if you can ask me or you can text me, so that if any doubts or if you look into the recording so that I can address tomorrow as well. If there is no doubts, let's wrap the session for today and we can connect tomorrow.
Thank you.
Yeah, thank you guys, have a great day ahead. Tomorrow we'll meet tomorrow. Good day, thank you, bye.